Good afternoon, Mr. Ike.
Yeah, good afternoon. How are you? Sit down.
I'm very fine.
So today we'll be looking at Ohm's law. Ohm's law. Okay. But before we move on to Ohm's law, I quickly want to remind us what we did in the last class, where we talked about current. You can remember?
Yes,
Yes. Then we talked about voltage and the like. So today we'll bring everything together. Isn't that so?
Yes,
We'll
sir.
bring everything together. But before we move on, quickly let me slide our objectives for today. So at the end of today's lesson, I expect us to know about Ohm's law. So if you're able to state Ohm's law, identify electrical instruments used in verification of Ohm's law, connect an electric circuit to verify Ohm's law, as well as solve basic calculations on Ohm's law. So those are the things that we hope to achieve in this class. Is that clear?
Yes, sir.
Ohm's law. You could take this down first before I explain. Right. Ohm's law states that the current passing through a metallic conductor, such as a wire, is directly proportional to the potential difference across its ends, provided that temperature and other physical properties of the conductor remain constant. For instance, what do we have here? This is a piece of wire. Okay?
Yes.
Now, if I have current passing through this wire, like I will soon display to you, we expect that the current is directly proportional to the voltage, inversely proportional to the resistance. What are we saying? According to Ohm's law, the voltage is proportional to the applied current. I don't know how you can remember what you've been taught in mathematics under proportionality. When you say something is directly and indirectly proportional.
Yes.
So according to Ohm's law, we are saying that the voltage is directly proportional to the what? To the current. In that case, voltage is equal to a constant times the current. So the constant in this case, we're going to call it R, the resistance. What did I say?
R, the resistance.
So we'll call it R, the resistance. So correct it as V is equals to Ri, or better as V is equals to IR. So based on this relationship, if I happen to make my resistance the subject of the formula, then my current will come down here, and that leaves me with VI is equals to R, or better still, R is equals to V over I. Now, what do you observe between R and I? We have an inverse relationship between them. Okay? Meaning that as the resistance is going up, we expect the current to be doing what?
Going down.
Going down. So if the current should go up, the resistance should equally do what? Go down. So an inverse relationship. So between the resistance and the what? And the current. Is that clear?
Yes, sir.
So looking at our table here, we can see some of the apparatus we'll be using to explain Ohm's law. Okay? And these apparatus are in line with this circuit diagram. So this is what we call a circuit diagram. Now, diagrammatically, the things we have here can be represented by the electrical equipment we have here. First, all these places you see as lines, these lines like this, they are the wires. They are the connecting wires. This symbol is for the battery. So we're going to make use of a 3-volt battery. Look at this. This is a 3-volt battery. This is a 3-volt battery. And here you can see the positive and the negative side of the battery. So this side with the big stroke is for the positive, while this side with the small stroke is for the negative. So we can see that there is a wire connected to the positive end of the battery that goes to the variable resistor. This is what you call a variable resistor. This is a variable resistor. And a variable resistor, for instance, means a resistor that can change its value. That's what we mean by variable. So if you look at this resistor closely, there are numbers here. 1, 2, 3, 4, 5. So there are numbers. There are numbers on the variable resistor. Can you see it?
Yes, sir.
So the numbers here, if for instance I want 1, if I want 1 ohm, I will open this place and I will remove this. Now I have 1 ohm. Okay? If I want 2 ohms, for instance, what will I do? I will return this one that is 1 and remove this one that is what? 2. So any one I want, what do? I just remove it. Then if I want 3, I will remove 2 and I will remove 1, and so on and so forth. So what we will do is we will try to change the various resistance and see the effect in the change of current. Is that clear?
Yes, sir.
Now, if you look at this instrument, this is called an ammeter. This is called an ammeter. What did I call it?
An ammeter.
It's an instrument used for measuring current. An instrument used for measuring current. So being that it's used for measuring current, you can see here 0 to 2. This means that I can use this to measure current of up to 0 to 2 amperes. Okay? I can also use it for 0 to 5. If I connect it to the one of 2 here, it means that I can measure up to 2 amperes. But if I connect the wire up to the one of 5, I can measure up to what? 5 amperes. So how do you know which one to connect to? Very simple. Depending on the question. If you have a question where, for instance, when you do the connection, it goes beyond 2 or it goes to 2 at the extreme, it means our current most likely is more than 2. So in that case, you are required to connect in the one that is 5 ampere. But if you connect it and you notice that your readings are less than 2, then stick with 2. It will give you more accuracy for your reading. So this is the ammeter for measuring current. Then this is the key. This is called a key or a switch. It does a similar function as your normal switch that you have on the wall for switching on the light and putting on the light. So this is the switch, the key that we're going to use. So I think those are the major component parts. What is left is for us to connect them. So what I want you to do for me now is you will attempt connecting this on your own. Then I will see how I will guide you along with it. I want you to follow the diagram. The positive end to the variable resistor. Then you connect the variable resistor to the ammeter. When you come to the ammeter, sorry, to the key first, you connect to the key. After the key, then you connect to the ammeter. So when you connect to the ammeter, notice that the ammeter has 2 ends, positive and negative. So where do you connect it to? You connect it to the positive side of the ammeter. Why is that so? Because we are tracing this thing from the positive end of the battery. So because we are tracing from the positive end of the battery, any other instrument you are coming into that has positive or negative, you must connect to that end. So if we come into the ammeter through the positive, we come out through the negative of the ammeter, and then we return back to the negative of the battery. Okay? So let me see you attempt it. Don't be scared. It's not so difficult. So come closer. A lot of you should put your heads together. It shouldn't be only one person. If you have any questions, you can ask me. If you have any questions, you ask me.
Yes, sir.
Some people are just looking, they don't know what we are doing. Ensure it is tight. Ensure the connections are tight. Which one is the positive of the battery? Where is the positive? Okay. How do you know it's positive?
There's a plus sign.
Okay, there is a plus sign there. Okay. don't put okay, you mean for which one? 2 or 5? Put it for 2. Use 2 first. I told you use 2, then if the thing gives you a maximum 2 deflection, then you can now switch to 5. So try 2 first for more accuracy.
From the battery to the
Please make sure you are following the diagram. Make sure you are following the diagram. Follow the diagram. Correct. Move the other side. Are we done? So what's happening now? Is it moving?
No.
Eh?
No, it's not moving.
Are we sure? Press the battery first. Press the battery. Press the battery. It's not moving. Let me see the ammeter.
The ammeter is not moving.
Leave the ammeter up. Let me see. So the ammeter is not moving.
No, it's
That
not.
means there is something wrong with your connection. Look at it very well. Something is wrong with the connection. Look at the diagram. Look at the diagram and look at what you have done. Look at your diagram and look at what you have done.
From the positive.
Who has an idea of the mistake, what you have done that is wrong? Look at the diagram. Compare it. Check the connection. Don't check the connection of the diagram. Then compare it with what you have just done. Trace it one by one.
Okay, so we made a mistake.
Made a mistake. Okay. So what's the mistake?
So we no connect positive to the right place.
That's which of the positive is that?
From the volts
Of the
to
battery. Okay. So try and do that. I think that's true. You connected it the other way around, right?
You have to exchange.
So you have to exchange it exactly. So correct it. Correct it. Is it moving?
This wire is too short.
Are you sure the connection is intact?
Yes, I will exchange the positive and the negative. It's very too short. What's a small hand? Which is almost small.
If the wire is short, try and cut.
Just wrap it around it.
Don't you have another wire? Try and cut out wire now. You're afraid to. You don't have any blade. You don't have any blade here. Use your mouth, sure.
Not sure.
You can use this one.
It's not on it yet.
What's still? You've not yet closed it. You've not yet closed your key. You have to close your key. Okay. Do you have a deflection?
Yeah.
Let's see. Okay, so it's the ammeter is deflecting.
Yes, I know.
You can't really see it very well. Can you bring the ammeter closer? Bring the ammeter closer.
Careful.
is 0, and then when I press it, it will not show when it goes from 0 to 1.
I'm pressing it right now.
No. Yes, now come back.
And then the finish connecting. Be careful for this. The key.
Yeah, who's going to move your account? Move it towards the camera. Wait, don't press it.
Is it moving?
Yes.
Let me see whether it's. Oh yeah, it's not really. It's on 0 now. Is it moving? Okay, so what's the reading now? Who can give me the reading? Are you reading the one up or down?
The one up.
Why is that so?
That's where there is
2. You know I told you 2. But if that pointer had gone beyond 2, if the pointer had gone beyond 2, let's say it was on 2 exactly, it means there is a possibility for it to be more than 2. So hence we will not use that one that is up. We will not connect the wire to the one that is 5. But since it's less than 2, we are okay with the 2 that we have there. So someone should take the reading down. That's what? What's the value? What can you read? What's the value? Record it. Just record the value.
0.54.
0. Are you sure?
Yes, sir.
0.54.
Yes, sir.
Huh?
Yes, sir.
0.54.
Record it down.
How is 0.54? Look, you have 10 divisions between 0.5 and 0.1. You have 10 divisions now. So two divisions will give you a 0.1. Are you getting me? So how many divisions do we have there from 0.5?
So 0.75.
0.75, right? That's 5 divisions.
Yes.
So 0.75. That means now, look at our resistance box. Look at our resistance box, for instance, now. We've not yet removed any of the resistances. So when the resistance is 0, our ammeter reading was what? 0.75 amperes. You must put it because that's the SI unit. Is that clear?
Yes.
Then if I remove, let me say I remove 1 ohm now. That means the reading is now 1 ohm. Do you observe that as the reading is now 1 ohm, the current has done what? Drop. So now the resistance is increasing from 0 to 1. The R resistance is increasing from 0 to 1. And the current is doing what? It's dropping. That's what I was showing you earlier on the board. That's the relationship of Ohm's law. So someone should take that reading down for us. That's what? What are you seeing?
0.5.
0.5. Is it 0.5?
It's past 0.
And when you are taking your readings on the ammeter, look, your eye must be vertically direct to avoid error due to parallax. So vertically direct. Are you getting 0.5?
0.55.
Is each division 0.5? 0.05?
Yes.
Okay, so put it down. So when it is 1 ohm, so I will return the resistance back, okay, and we'll tighten it. Ensure you tighten it. Now the next one is, let's take for 2. So someone should remove the 2. Someone should remove 2 ohms. So once you remove it now, it means that this is for 2 ohms. What's the reading? Hold the battery well. What's the reading you can see? 0.35.
Yes,
So that means when the resistance is when the resistance is 2, we now have what? 0.35. Let's do one more. When the resistance is 4, how do we achieve 4? Do we have 4 on the resistance?
No, sir.
So we can remove 2 and 2.
Yes.
2 and 2 give us 4. Oh yeah, go ahead. Okay. So what's the reading?
0.3.
Look at it very well.
Yes,
0.3.
0.3.
Okay, so we now have our readings. So we can use our readings and we can now plot values on it. Okay? You can go back to your seats.
Thank you so much.
Based on what we've done now, let's look at the values that we got. You have them. Let's create a table of resistance and current. Okay? Then this is serial number. So the first one we did, our resistance was 0. What was the current?
0.75.
And mind you, when you draw your table, you put slash, then you put the symbol of the parameter. Like now, this is ohms. Ohms is the symbol for resistance. Then current is ampere, so it says slash ampere. So 0, when we have 0, what's the current? 0.75. So in the table, you don't need to write the symbols again, since you already placed it on top this way. So you don't need to write it inside the values there. The second one, when our resistance was what? 1, what did we get? 0.55. The next one, when our resistance was 2, what did we get? 0.35. Then which other one? That was 4, right? What was our current? 0.30. So what do we notice as a pattern? As our resistance is increasing in value, there is a decrease in what? Our current. So based on what I said earlier on, when V is equal to IR, if I make my R is equal to the formula, that will give me R is equal to V over I. It means as R is increasing in value, I is doing what? Decreasing in value. Okay? So a simple calculation question can look like this. You can take it down. Simple calculation question says, determine the voltage in a circuit if the current is 5 ampere, and the resistance is 2 ohms. Okay? If the current is 5 ampere and the resistance is 2 ohms, determine the voltage. So given a question like this, the first thing you write are the parameters given. We are given that the current is what?
5 amperes.
Then the resistance is what?
2 ohms.
2 ohms. Okay? Then we are looking for the voltage. Let me put a question mark. So to get the voltage here, we just say, quoting our formula, V is equal to what? IR. Then the V is equal to current, which we said is what? 5 times resistance, which is what? 2. That will give me what? 10 volts. So it's as simple as that. Okay? So for your assignment, you will just, the same question, but this time around, let your current be 2 ampere and your resistance, okay, let me do this so you can find this thing. Let your current be 2 ampere, the voltage 20 volts, so that you can find the resistance. Okay? Is that clear?
Yes, sir.
Any other questions?
No, sir.
Ask questions, please. Somebody must ask a question.
Sir, I have a question.
What's the question?
So what is that in our reading? We were taking our reading. Why do we not start? Why don't we have 0 in one of the serial numbers
Which one
in
is
the
it?
table?
Where? You mean
Yes,
here?
yes.
No, serial number just means the number of the experiment that you took. The 1 here represents the first experiment, second experiment, third experiment, fourth experiment. So we're not saying the 0th experiment. So our experiment starts with experiment number 1.
I have a question.
Yes.
So can you determine the current, like when the resistance is like a decimal, which is like 4.5?
Yes. Yes. The resistance we have here are whole numbers, but it's possible that we can have resistance that are decimal. So if we have like maybe a resistance that is digitized, are you getting me? A variable resistance that is digitized, you can say, okay, you want 2.5 ohms, 3.4 ohm. Okay, but in this case, this one we're using is analog. This is the basic form. So that's why we're working in whole numbers. Even our ammeter that we use, we're just using the analog. This ammeter we use is an analog form of it. There are digital ammeters that we can use. So probably when you get to high institution, depending on where you further your education, you'll be exposed to things like this. But at this level, this is enough for your WAEC, NECO, and that. Any other questions? Okay? So, in the event of no other questions, we'll call it a day. So we'll continue from here.
Thank you, Mr. Ike, for imparting knowledge on us. Remain blessed and stay safe.
Remain blessed. God bless you all.